This is William Michael, the headmaster of the Classical Liberal Arts Academy, and in this video, I'd like to provide students with help that they need to work through all of the content of Section 2 of Chapter 1 in elementary algebra or Algebra 1. These lessons have a lot of content in them, and what teachers usually do is just pick and choose what they want to teach, and they often leave out some important things. I would like to not do that, so I would like for us to simply read through the entire section and make sure we cover all of the content and understand everything clearly. Remember, in the first lesson, I said our goal in studying elementary algebra is not necessarily to use it in everyday life. It's not like studying sacred scripture or moral philosophy or Aesop's fables, even. Many of us, most of us, will never use algebra in daily life, but it's required for our high school diploma studies, and therefore we should pursue it and should study it as well as we can for the sake of our high school diploma and transcript and so on. So let's continue our study here, moving into this second section in Chapter 1, which is really an introduction to the study of algebra. And we can see here that the title of this section is To Use the Language of Algebra. Use the language of algebra. And that may sound strange because algebra is a math course. So why are we talking about language? And the reason is because we use symbols to communicate in algebra in the same way that we use symbols to communicate in language. We use letters and punctuation marks, things like that, to communicate in language, in written language. Well, there's also a language of algebra because we use symbols and to represent different ideas, just like letters. So in section 2 here, we're going to learn to use the language of algebra. And again, while these lessons may seem simple, many times students who struggle later on in high school math, Algebra 2, for example, it's because they never really understood the basic concepts that they learned in elementary algebra. So let's take our time, work through the lesson, read every part, and make sure we understand what's in here. Make sure we understand how to use the language of algebra. We see here that there are 5 objectives for this lesson. By the end of this section, you will be able to use variables and algebraic symbols. Simplify expressions using the order of operations. Evaluate an expression. Identify and combine like terms. Translate an English phrase into an algebraic expression. Now, even in reading those objectives, you may say, I don't know what all these words mean. Well, that's what we mean by the language of algebra. We've got to learn the vocabulary of algebra. We've got to learn the meaning of the symbols, how to express different ideas, how to translate a phrase into an algebraic expression. You can see how all of this has to do with the language of algebra. So let's go ahead and get started. And by the end of the section, we'll review these objectives and see how we've done. The first section, we read to use variables and algebraic symbols. And notice that this section is simply the first objective. All right, so make sure you understand the order of this textbook because that will help you to study it. So this first objective or goal here in this section is to use variables and algebraic symbols. We're going to have to learn what these words even mean. So let's go ahead and read together. Suppose this year Greg is 20 years old and Alex is 23 years old. You know that Alex is 3 years older than Greg. When Greg was 12, Alex was 15, 3 years older. When Greg is 35, Alex will be 38, 3 years older. No matter what Greg's age is, Alex's age will always be 3 years more. No matter what Greg's age is, Alex's age will be 3 years more. See how that's a general rule for the ages of these two men. No matter what Greg's age is, Alex's age will be 3 years more. In the language of algebra, we say that Greg's age and Alex's age are variables. Greg's age and Alex's age are variables. What does that mean? It means that they can vary, they can change. Greg's age and Alex's age can change. But the number 3 is a constant. The number 3 is a constant. The ages change or vary, but the 3 years between their ages always stays the same. That's what it means to be constant. So there's a relationship between their ages. Their ages may vary, they're variables, but the difference between them is a constant. Since Greg's age and Alex's age will always differ by 3 years, 3 is the constant. In algebra, we use letters of the alphabet to represent variables. Now, why would we do that? Why would we use letters of the alphabet to represent variables? Because they can change. The numbers can change, and so we can represent a variable by using a letter rather than a number. And you see, the letter that represents the variable represents this idea. No matter what Greg's age is, no matter what the age is, for any age, that's the idea of a variable. That's why we use a letter to represent a variable. So if we call Greg's age G, so G is a symbol that represents Greg's age, we could then use G plus 3 to represent Alex's age. If we make Greg's age G, we use G to represent Greg's age, we could then represent Alex's age by G plus 3, because whatever G is, whatever Greg's age is, Alex's age will always be 3 more than G. So you see how we express that using algebraic language. And they give us a table here which shows that if Greg's age is 12, so G is 12, then Alex's age is equal to G plus 3, 12 plus 3, which is 15. If Greg's age is 20, G equals 20, then Alex's age equals G plus 3, which is 23. So you can see how we can express the ages of these two men using algebraic symbols. And here we have that summarized at the bottom of this table. Whatever Greg's age is, which we represent with the letter G, Alex's age will be equal to G plus 3. Pretty simple. The letters used to represent these changing ages are called variables. Notice that it says the letters that are used are called variables. The letters most commonly used for variables are X, Y, A, B, and C. So the letters are used to represent variables, quantities that can change. And here we have the definition of variable and constant. And remember, anytime we have a definition, that's very important because this is learning the language of algebra. And again, in future lessons, this is the kind of stuff that causes students trouble. They just don't learn the meaning of terms and symbols. So let's learn, and you should memorize and write down the definition of a variable. A variable is a letter that represents a number whose value may change. A variable is a letter that represents a number whose value may change. A constant is a number whose value always stays the same. A constant is a number whose value always stays the same. So we saw the variable here when speaking of the men's ages. The variable was G, and the constant was the 3. The difference between their ages is always +3 or +3. So we have a variable and a constant, and that's our vocabulary here in this first section. To write algebraically means in a way that's useful for algebra. To write in a way that's useful for algebra, to write algebraically, we need some operation symbols as well as numbers and variables. We need some symbols that represent operations. There are several types of symbols we will be using, and this is quite simple, right? There are 4 basic arithmetic operations. And notice the difference between the word arithmetic and the word algebra. Arithmetic has to deal with specific quantities that are known. We add 6 plus 4. That's what we do in arithmetic. We multiply 6 times 2. We divide 18 by 3. That's arithmetic. In algebra, as you can see here, we're dealing more with general rules and with situations where quantities can change. So we're trying to define things and express things to allow for change, because in real life, we've got to calculate things that can change, and that's much more complicated than arithmetic where the quantities don't change. So there are 4 basic arithmetic operations: addition, subtraction, multiplication, and division. We'll list the symbols used to indicate these operations in the table below. You'll probably recognize some or most of them. So let's take a look. We've got the 4 basic operations here on the left, 4 basic operations. And then we're shown how they are expressed in algebra. And we see that we're using letters instead of quantities. And remember, we learned that these letters are representing variables. A variable is a letter that represents a number whose value may change. So it's different from arithmetic. So to express addition in algebra, to write algebraically, you can see that we would show that the quantity A is being added to the quantity B. We can read this. To read this algebraic expression, we would say A plus B. You can see that written here. So we read this as A plus B. The result of this is the sum of A and B. So this expression is equal to the sum of A and B. For subtraction, you can see we simply write A minus B. A minus B. And this expression is equal to the difference of A and B. Now you can see when we get to multiplication and division, there are a number of different symbols. So some of these you might need to learn. So we'll go through them clearly here, and we'll talk about them more further down in the lesson. So for multiplication, first, we can express multiplication using this dot. We can see A times B. Now, why do you think we would use a dot in algebra rather than the multiplication symbol that we use in arithmetic? In arithmetic, we use an X-shaped symbol, right, a cross symbol to express multiplication. Why would we not do that in algebra? Why would we use a dot for multiplication in algebra? The reason why is because we often use the letter X to represent a variable. And you can imagine that if we're using the letter X with the cross multiplication symbol, things could get pretty confusing. So it's better in algebra to use a dot rather than that X sign for multiplication. So A with this multiplication symbol and B is read as A times B. A second way to express multiplication in algebra is to simply put the two variables together like this, AB. This is expressed as A times B. So two variables written together like this expresses multiplication, A times B. We can also put them in parentheses like this. This is the quantity A times the quantity B. And we can also do it with one of the variables in parentheses and one not in parentheses. This would be read as A times B, and this would be read as A times B. So all of these are ways to express multiplication in algebra. Division, we can use the regular arithmetic division symbol here, A divided by B. We can also use a slash here, A divided by B. We can also represent division as a fraction, A divided by B. And we can also use this symbol here where we write A inside the bracket divided by B. So A here is what's called the dividend, the number to be divided. B is called the divisor, the number that is dividing, the divider. So we put the dividend inside the bracket and the divisor on the left side of that symbol. So these are all different ways of expressing division in algebra, and any one of them or all of them is read as A divided by B. So again, we're learning here the language of algebra, how to read and write algebraic expressions. Let's keep reading through the lesson here. We perform these operations on two numbers. When translating from symbolic form to English, or from English to symbolic form, pay attention to the words of and. The difference of 9 and 2 means subtract 9 and 2. In other words, 9 minus 2, which we write symbolically as 9 minus sign 2. The product of 4 and 8 means multiply 4 and 8. In other words, 4 times 8, which we write symbolically as 4 with that dot operator sign, and 8, 4 times 8. In algebra, the cross symbol is not used to show multiplication because, as I already explained, that symbol may cause confusion. Does 3xy mean 3 times y or 3 times x times y? So that could be confusing. To make this clear, we use the dot operator or parentheses for multiplication, and you can see all of that up here in this chart. So we don't use the X sign for multiplication in algebra because it can cause confusion. When two quantities have the same value, we say they are equal and connect them with an equal sign. When two quantities have the same value, we say they're equal. So we can see this. It looks just like arithmetic. We can read this as A is equal to B, or A equals B. The symbol is called the equal sign. So A equal B. Now, the reason why this is so important in algebra is because when we have two quantities that are equal, that means one can be used in place of the other at any time. If A is equal to B and we see A in an equation, we can replace it with B because they're equal. They have the same value. So two symbols in algebra or two expressions in algebra that are equal can be used in place of each other. And we'll see as we go on in our studies why that's so important. But this is the equality symbol and should be pretty simple. Let's keep going here. On the number line, which we learned about in our first lesson, on the number line, the numbers get larger as they go from left to right. The number line can be used to explain the symbols less than and greater than. That's what these two symbols mean, less than and greater than. You can see that this symbol points to the left, and if we think of the number line, when we move to the left, quantities get smaller. This symbol points to the right, and when we move on the number line to the right, quantities get larger. A, and this symbol, this less than symbol, and B is read as A is less than B. A is less than B. A is to the left of B on the number line. A is to the left of B on the number line. So A is less than B. You can see that drawn here on the number line. A is to the left of B. A is less than B. Here we see A is greater than B. A is greater than B. A is to the right of B on the number line. A is to the right of B on the number line because A is greater than B. Now again, most of these symbols you've probably learned in algebra, but it's just good to review because remember, we're trying to build a foundation for our algebra study. The expressions A is less than B or A is greater than B can be read from left to right or from right to left, though in English we usually read from left to right. In general, A is less than B is equivalent to B is greater than A. So we can read these expressions in either direction. We can start on the left and say A is less than B, or we can start on the right and say B is greater than A. For example, 7 is less than 11. That expresses the same idea that we read when we say 11 is greater than 7. A is greater than B is equivalent or equal in value to B is less than A. 17 is greater than 4 is equivalent to 4 is less than 17. And these are called inequality symbols because up here we learned about the equality symbol when things are equal. But here we're learning about the inequality symbols when quantities are not equal. And we express their relationship in a number of different ways, and it's summarized in this table here. If two quantities are not equal, we can simply say A is not equal to B. We make an equal sign and put a slash through it. A is not equal to B. We may not know what A or B are, but we know that they are not equal to one another. Here we see A is less than B. A is less than B. Here we see the less than symbol with part of the equal sign symbol underneath it. So we read this as A is less than or equal to B. A is less than or equal to B. So this is saying A is not greater than B. A is either less than or equal to B. Here we see A is greater than B. Here we see A is greater than or equal to B. A is greater than, let me get back there. A is greater than or equal to B. This is equivalent to saying A is not less than B, but is greater than or equal to. So we see all of the inequality symbols here, and they're different translations, so we can read them correctly written over here. And you'll need to practice this. If you're already comfortable with this because of your studies in arithmetic, that's great. But if not, this is your opportunity to understand it by studying. Let's move on here. We've got some examples. You see here that you're asked to translate from algebra as if it was a foreign language into English. And you're given this expression here as if it's just a foreign language, like you're reading Greek. And we now understand how to read this. 17 is less than or equal to 26. For letter B, we see things get a little more complicated, but we're just going to put together all the things that we've learned in the lesson. 8 is not equal to 17 minus 3. 8 is not equal to 17 minus 3. Now, if we solve 17 minus 3 and get 14, we'll see that this says 8 is not equal to 14. But our focus here is just translating from algebra into English. Next, letter C, we read 12 is greater than 27 divided by 3. 12 is greater than 27 divided by 3. That's all you need to do for this exercise. And for letter D, we see the quantity y plus 7 is less than 19. Y plus 7, whatever y may be, when it's added to 7, the sum is less than 19. And so we've got these solutions written out down here, which we've just gone through. So go through these exercises on your own. Make sure you can get them all correct. If there's anything in here you don't understand, just go back up and review. And if after reviewing you still can't understand something, that's when you should get in touch and let us give you some help, okay? But work through those examples by yourself. You're given some more down here. Just practicing translating from algebra into English, which is very important as we get started. In the next section, we see what are called grouping symbols. So we're continuing to learn more about the symbols used in algebra. Here we're learning about grouping symbols. Grouping symbols in algebra are much like the commas, colons, and other punctuation marks in English. They help to make clear which expressions are to be kept together and separate from other expressions. We will introduce 3 types of grouping symbols now. And so we've got, you see, 3 different sets. 3 different sets of symbols, and you can find these on the keyboard of your computer. If you're sitting at a keyboard, see if you can find them. 3 different kinds of grouping symbols, and we'll see them used in algebraic expressions. So these different symbols, and you should make sure you know the name and the symbol for each one. There's a difference between parentheses, brackets, which are square, and braces, which are squiggly, like they look like 2 mustaches. Parentheses, which are round, brackets, which are square, and braces, which are curly. 3 different kinds of grouping symbols. Here are some examples of expressions that include grouping symbols. We will simplify expressions like these later in this section, so you don't necessarily have to understand how to translate or read these expressions. They're just showing in the text here how these grouping symbols are used. You can see that 14 minus 8 is set inside of 2 parentheses. So 14 minus 8 is grouped inside parentheses. Here we see 9 minus 8 is put inside parentheses and grouped, but then we see this whole expression here is grouped inside of square brackets. You can see the square brackets before the 2 and after the 8. So we have parentheses inside of brackets. And then here it gets even more complicated. We see parentheses grouping 6 minus 5 inside of brackets, and the brackets are inside of braces. And that's really how these different symbols are used. Parentheses are used first. Then if we need to group something further, we move from parentheses to brackets, and then if we need to move further, we use braces. So you can see the parentheses, the brackets, and the braces used here to group different expressions together, and we'll learn more about that later. All right? So 3 different grouping symbols. What is the difference in English between a phrase and a sentence? What's the difference between a phrase and a sentence? A phrase expresses a single thought that is incomplete by itself. Incomplete by itself. That's what makes it a phrase. It's a single thought, but it's not a complete thought. A sentence makes a complete statement. A sentence is a complete statement. A phrase is part of a sentence. It's an incomplete statement. We see an example here. Running very fast. Running very fast is a single thought, but it's incomplete by itself. It's a phrase, running very fast. Here we have a sentence. The football player was running very fast. So here we can see that phrase, running very fast, set in a complete thought, a sentence. The football player was running very fast. That's a sentence. So make sure you understand the difference between a phrase and a sentence. A phrase is a part of a sentence. A sentence has a subject and a verb. A subject is what we are talking about, and the verb expresses some action or state of being for the subject. In algebra, we have expressions and equations. We have expressions and equations. So we're showing how the language of algebra compares to the grammar of English. In algebra, there are expressions and equations, and we're going to learn the definitions down here. So remember, you need to take time to learn every definition you come across. So these are the kinds of things you should jot down in your notes, take time to memorize, and so on. What is an expression? An expression is a number, variable, and remember, we learned the definition of a variable earlier in this section. It's a letter that's used in place of a number that may change. An expression is a number or a variable or a combination of numbers and variables using operation symbols. An expression is a number, a variable, or a combination of numbers and variables using operation symbols. An expression in algebra is like a phrase in English. An expression is like a phrase. Here are some examples of expressions. So we're given 4 examples of expressions in algebra. We're taught how to read them. This expression says 3 plus 5. This expression says n minus 1. Notice it doesn't say anything else about this quantity. It just expresses the quantity. It's an expression. N minus 1. 6 times 7. And x divided by y. So 4 expressions, like phrases in English. Notice that the English phrases over here on the side column, notice that the phrases do not form a complete sentence because the phrase does not have a verb. These phrases are not sentences. They're expressions in algebra. And so if an expression is like a phrase, well then what's like a sentence? An equation is like a sentence. So let's read here. An equation is 2 expressions linked with an equal sign. Notice the word equation. Equation is two expressions linked with an equal. Notice equation and equal. So an equation has an equal sign. It shows that two expressions are equal to one another. When you read the words the symbols represent in an equation, you have a complete sentence in English. The equal sign gives the verb. What does that mean? The equal sign gives the verb. The equal sign is basically equivalent to the verb is, right? To say that A equals B is really like saying A is B. So the equal sign acts like a verb in a sentence. Here we have the definition of equation. An equation is two expressions connected by an equal sign. An equation is two expressions connected by an equal sign. So let's look at some examples. Notice we've got a bunch of stuff written in these boxes. But what's really significant is that we've got an expression here, 3 plus 5. We've got an expression over here, 8. And then we've got the equal sign connecting the two expressions and acting like a verb. 3 plus 5 equals 8. 3 plus 5 is 8. See how the equal sign acts like a verb that turns these two phrases into a complete sentence. 3 plus 5, the expression, is equal to the expression 8. And that whole statement is an equation with an equal sign connecting two expressions. Here we see the expression n minus 1 joined to the expression 14 with an equal sign, making this a complete sentence in algebra. It's an equation. Here we see 6 times 7, that expression, equals 42, a second expression. And that makes a complete sentence in algebra. 6 times 7 equals 42. Here we see x, one expression, is equal to 53. Here we see the expression y plus 9, and we see the expression 2 times y minus 3, and we see them joined together with an equal sign, making an equation or a complete sentence in algebra. Y plus 9 is equal to 2y minus 3. So make sure you understand at this point the difference between expressions like y plus 9 and equations like y plus 9 equals 2y minus 3. Here we have some examples, and you're asked to determine if each of these statements here determine whether it's an expression or an equation. So read what's written here in algebraic language and determine if it's an expression or an equation. 2 times the quantity x plus 3, grouped in parentheses, 2 times the sum of x plus 3, that's one expression, is equal to 10, another expression. Letter A here, this is an equation. This is an equation. For letter B, we see the difference of y and 1, y minus 1 set in parentheses, times 4, and the product of 4 times y minus 1 plus 1. This is an expression. Even though there's a number of different parts, it's an expression. It's not an equation because there's no equal sign. For letter C, we have x, one expression, divided by 25. So we have an expression here because there's no equal sign. We don't have an equation. And here we've got y plus 8, which is an expression, is equal to 40, which is another expression. But two expressions joined together by the equal sign makes an equation. And so you can see those answers explained down here in the answers. And then you're given a number to try on your own. See how comfortable you are with this? If you struggle, go back and review the lesson. And if after reviewing there's still something you don't understand, get in touch with us so that we can help. Let's move on here. And remember, as we go through these lessons, you can pause these videos at any time. So if I start moving too quickly and you'd like to go back and review or reread something, just hit pause and do so. You can go through this video as slowly or as many times as you'd like. I'm just going to keep moving through the lesson because you can stop me. It's not like being in class together. Let's go on here to this next section. We're going to continue learning the language of algebra. Continue learning the language of algebra. Let's suppose we need to multiply 2 9 times. Let's suppose we need to multiply 2 9 times. We could write it like this. What a nightmare this would be. 2 times 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 2. That's a real pain in the neck, and you can imagine having to write like that. You could add 1 2 too many or leave 1 2 out and end up with bad results. It's like praying the rosary where you're going through the Hail Marys and it's hard to remember how many you've done, right? It's not a good idea to list out all of the numbers to be multiplied by like that. So maybe there's a better way to express this same idea rather than writing it all out. This is tedious. That means it's troublesome. And it can be hard to keep track of all those 2's. So in algebra, we use exponents. We use exponents. We write 2 times 2 times 2. So multiplying 2 3 times. We write it as 2, and then we express the number of times that it's taken in this number, which is written above the line and in a smaller font, and that's called an exponent. So 2 times 2 times 2, instead of writing all that out, we just write 2 taken 3 times, or 2 to the 3rd power. We'll learn about that in just a bit. But you can see how this expression here, 2 times 2 times 2, is written in this way. And when we want to multiply 2 9 times, we can write it out like that with all these 2's, or we could just write 2 taken 9 times with 9 written as an exponent. In expressions such as 2 with 3 as an exponent, the 2 is called the base, and the 3 is called the exponent. The 2 is called the base, that's the number we're multiplying, and the number that shows how many times we're multiplying it is called the exponent. And you can see how that's written with a smaller font raised above the line. That's called superscript. So if you want to find that, let's say on your keyboard or in Google Docs or something like that, what you'll need is to find how to superscript. In expressions such as 2 taken 3 times, the 2 is called the base and 3 is called the exponent. The exponent tells us how many times we need to multiply the base. Very important sentence. The exponent tells us how many times we need to multiply the base. How many times? The base here is 2. The exponent tells us how many times we need to multiply 2. So if we see 2 with an exponent of 3, that means that we're multiplying 2 times 2 times 2. Now when we see this, the way that we read this, we learn here. We read this as 2 to the 3rd power. 2 to the 3rd power. Or we can say 2 cubed. Cubed means to the 3rd power. 2 to the 3rd power. And a short way of saying that is 2 cubed. We say 2 to the third power is in exponential notation. That is, it's written in a way that shows exponents. It's written in a way that shows that numbers, the base that is, the number is being multiplied a number of times, and that number of times is expressed by an exponent. That's called exponential notation when things are written like this. 2 times 2 times 2 is called expanded notation. So this is exponential notation, and this is expanded notation. And make sure you understand that this expresses the same exact idea as this. It's two different ways of expressing the same idea in algebra. 2 to the third power is in exponential notation. 2 times 2 times 2 is in expanded notation. Now here we have a summary of exponential notation, but notice that we're using variables here because these quantities can always change. So we're going to learn the concept with an example as we do up here, but then we want to learn a rule that applies in all cases, because that's what we're really seeking in algebra, is to understand general rules in mathematics. So we see that a to the nth power, a to the nth power, or a taken n times, is expressed like this, with a written as the base and n written as an exponent. A taken n times, or a to the nth power. We're shown that a is the base and n is the exponent. Here we see that written in exponential notation, and here we show that written in expanded notation. Notice in the middle of this, we have this dot, dot, dot. That's showing us that this exponent n is variable. So it's saying a times a times a, and this can go on for a certain number of times based on what the exponent is. So that's a way of expressing expanded notation, expressing this expression here and showing that it's variable, okay? And n refers to how many factors there are, how many times that base is being multiplied. The expression a with n as an exponent is read a to the nth power, a to the nth power. Okay, that's exponential notation written in a general way for our use in algebra. Let's keep moving here. While we read a with the exponent n as a to the nth power, we usually read a to the second power as a squared. So squared is just a way of expressing to the second power. A to the second power is called a squared. And a to the third power is called a cubed. So squared means to the second power, cubed means to the third power. Now, the reason why we say square and cube here, just so you understand this so it's not confusing or mysterious, is because if we think about a square has two dimensions, length and width. So having an exponent of 2 is like multiplying the length and width of a square. Whereas a cube has 3 dimensions. It has length, width, and height. So a to the third power is like multiplying the sides of a cube. That's why we say a squared and a cubed. All right, so don't let those words confuse you. We'll later see why a squared and a to the third have special names. I'm sure it's because of what I just said. All right, so here you've got a number of exponential expressions, and then they're translated into English language. So 7, the base 7 with the exponent 2 is read as 7 to the second power, or 7 squared. The base 5, written with the exponent 3, is written 5 to the third power, or 5 cubed. The base 9 with the exponent 4 is written 9 to the fourth power. And the base 12, which with the exponent 5 is written 12 to the fifth power. Notice that these special names are only used with the second and third powers. Everything else is just read regularly. 9 to the fourth power, 12 to the fifth power, and so on. So you should understand what the base is. The base is the number that's being multiplied, and the exponent shows us how many times the base is being multiplied. And you're given some more examples here where you're actually asked to find the solution for this, to simplify or express this in the simplest way possible. Simplify, you'll notice that often used in algebra, not used very often in arithmetic, but you'll notice that you'll be given some algebraic statement and be told to simplify it. That means to see if you can express this idea in a simpler way. And 3 to the fourth power, we can actually find the number that's equivalent to by multiplying 3 4 times. And that's what we do here. We multiply 3 times 3, which gives us 9, times 3, which gives us 27 times 3, and then we multiply that and we get 81. So we can simplify the expression 3 to the fourth power by writing 81, which is its equivalent. And then you're given some more examples here to work with. Make sure you try these exercises. Go back and review the lesson if you have any difficulty, and if there's something you can't figure out, just get in touch with us. And that brings us to the end of the first part of section 2 of lesson 1. So you can see this is a lengthy bit of content. And what I think we'll do is I think we'll stop here because we're at about 50 minutes. And I think we'll stop at the end of this first section, and I'll pick up the next section in another video. All right, so go through that first section, all of which deals with the first objective in our lesson. Make sure you read through it all on your own, understand the content, learn the definitions, learn the symbols, learn how to read everything in algebra. Challenge yourself with these exercises and then review and ask any questions you have. And we'll just continue to move through chapter 1. One piece at a time. I hope that's a helpful guide. Get through that, and I'll be ready to work with you in the next video. God bless your studies.